Hello to you watching this video. So for this video, we're going to discuss about module number 12, horizontal alignment. So in this module, we're going to explain, analyze, compute, and lay out horizontal curves. Okay. So what is a horizontal curve? So a horizontal curve or curves are one of the two important transition elements in geometric design for highways. So a horizontal curve provides a transition between two tangent strips of roadways, allowing a vehicle to negotiate a turn at a gradual rate rather than a sharp cut. The design of the curve is dependent on the intended design speed for the roadway as well as other factors including drainage and friction. These curves are semicircles as to provide the driver with a constant turning rate with radii determined by the laws of physics surrounding centripetal force. Okay, so ano ba yung horizontal curve? Para ma-imagine nyo, yung horizontal curve, yan yung mga zigzag. Yan yung zigzag sa kalsada. This one, yung transition from a straight line to a curvature. Yan yung purpose ng horizontal curve so that you can have a smooth transition from a one direction to another direction because a straight line gives us a one direction. So if we are going north, then we are going north. Then pag nagkaroon tayo ng horizontal curve, then we are diverting our direction from a straight path. Okay, I repeat, yung horizontal curve, yan yung mga zigzag sa kalsada. Okay, so the design of the curve is dependent and the the horizontal curve is also dependent. Okay, it is dependent on the intended design speed. When we say design speed, yun yung maximum possible speed pag trinaverse mo itong kalsada na to. Okay, so pag dumaan ka sa kalsada na yan, that would be the maximum possible speed. So if you're going to observe, isn't it that in roads, there are signages maximum speed or speed limit is 85 kph, 100 kph, yan. So may purpose yan. Hindi naman yan nilalagay dyan dahil gusto lang nung nag-design. So it was placed there because uh, it was computed. Okay? So, na-compute yung mga yan. So, the curves are semicircles as to provide the driver with a constant turning rate with radii determined by the laws of physics surrounding centripetal force. So, if you're going to imagine, okay, itong simple curve na to, this is part of a circle. Okay, so pagbubuin natin yung simple curve na yan by an imaginary dash line, we can create here a circle. And at the center, to the center line of your simple curve, that would be the radius. Okay? So, and that is of course with respect to the centripetal force of physics. Okay? So, since nagkakaroon tayo ng curvature, yung force natin mas uh, nakalina towards the center of the circle. Okay? Kasi kung titingnan mo, sa straight line, there is no centrifugal force kasi nakabalance yung speed and nakabalance yung speed and at the same time um, yung sasakyan, flat siya. Okay? Horizontal. But if we are now going to involve a curve here, magkakaroon na tayo ng centrifugal force with respect to the center of the circle. So, mas nagli-lean towards the center of the circle. So, if hindi mag-a-adjust yung speed and at the same time the embankment of the road, then therefore, magkakaroon ng outbalance yung sasakyan. So, pwedeng mag-cause ng accident. So, dito papasok yung laws of physics. Okay? So, the principal consideration in the design of a curve is the selection of the length of the radius or the degree of curvature. So, pag mas maliit yung radius natin, habang lumiliit yung radius natin, mas nagiging smooth yung yung ano natin, mas nagiging smooth yung curve natin. Habang lumalaki yung radius natin, mas nagiging sharp yung curve. Kumbaga, nagiging sharp curve siya. Okay? So, yun. So, this selection is based on such consideration as the design speed of the highway and the sight distance as limited by the headlights or obstruction. Okay? So, first is the design speed. So, if you're going to observe in highways, there are signages that are saying the speed limit is 85 kph, 60 kph, 100 kph. Those were placed there not because it is the desire of the authorities, no. It was placed there because it was computed with respect to safety. Okay, so safety ang number one priority natin dyan. So, kaya tayo may speed limit and kinocompute yung mga yan. Okay? And next would be the sight distance. So when we say sight distance, ito yung natatanaw ng mata mo, nakikita ng mata mo. So sight distance must be enough in such a way that if there is an object or obstruction uh, along the path, dapat malayo pa lang nakikita mong merong obstruction so that you can have enough time and distance to step in your brake to avoid accident. Okay? So yun yun. So some typical radii you may encounter are 12,000 feet or longer in an interstate highway. Okay? So 1,000 feet for a major thoroughfare in a city, 500 feet on an industrial access, and 150 feet on a minor residential street. So maliit lang yung radius natin pag residential street, no? So yan. Ang simpleng pagliko, we already have a radius there. So what are the types of horizontal curves? So first is we have here a simple curve. So the simple curve is an arc of a circle. The radius of the circle determines the sharpness or flatness of the curve. So I repeat, the lower the radius is, the flat, mas flat siya, but the higher the radius is, the more that the road becomes sharper with respect to curve. Next is a compound curve. So what is a compound curve? Frequently, the terrain will require the use of compound curve. This curve normally consists of two simple curves joined together and curving in the same direction. So there will be times na hindi kaya ng isang simple curve, but simple curve dapat yung i-apply. So ngayon, ang gagawin natin, pagtatabihin natin yung dalawang simple curve na magkaiba yung radius. And that becomes a compound curve. Number 3, we have here a reverse curve. So a reverse curve consists of two simple curves joining together but curving in the opposite direction. So magka-opposite yung location ng kanilang radius. Okay? So for safety reasons, the use of this curve should be avoided as much as possible. And lastly, we have the spiral curves. So the spiral is a curve that has a varying radius. This is used on railroads and most modern highways. It provides a transition from the tangent to a simple curve or between simple curves in a compound curve. Okay, so this is a simple curve. So if you're going to see here, you have your point of tangency here and your point of tangency here. So ito yung straight na kalsada, diretsong kalsada. On the point of tangency, dyan na nag-start yung transition. So meron na tayong smooth transition of a curve from one direction to another direction. And ito yung radius natin. So if we are to imagine, here we have a circle and nandito yung center. And we have here a radius. Okay? So this is a compound curve. So a compound curve is a combination of two simple curves with different radius. So simple curve 1, simple curve number 2. And number 3, we have the reverse curve. So ito yung nandito yung radius ng isang curve. Nasabi ko kanina na magkaibang direction. Pwede rin 'yon. So, pwede tama. Tama. Sorry. So magkaiba yung opposite yung radius natin. If you're going to imagine this simple curve here, the radius is here and yung simple curve naman ng isa is here. But for safety concerns, based on studies din, as much as possible, we want to try to avoid this kind of curve. Okay? And lastly, we have here the spiral curve. Okay? So what are the elements of a horizontal curve? So number one, we have the point of intersection. Wait. Okay, so given naman siya dito. Point of intersection is the point where the back and the forward tangent intersect. Sometimes the point of intersection is designated as the vertex. Okay? So we have here our back tangent, we have here our point tangent. So the point of intersection or the PI is where your forward and backward and forward tangent intersects. So ito yung backward, ito yung forward, dito sila intersect. So this is my point of intersection. Next would be the radius. The radius is the distance from the center of a circle or curve represented as an arc or segment. The radius is always perpendicular to the back and forward tangent. So if this is your, okay, imagine natin, if we are to complete this, magkakaroon tayo dito ng circle. And yung gitna, nandun yung center of gravity. Now, as per definition, the point of tangency between the curve and your straight line, kung saan mag-umpisa yung curve, that would be the point of tangency. And sa point of tangency, itong radius natin and itong tangent line natin will always be 90 degrees. Likewise with this, our radius and our forward tangent will always be in perpendicular orientation. So 90 degrees din tayo dito. So we have here PC or the point of curvature. The point of curvature is the point of the back tangent where the circular curve begins. So point of curvature, diyan mag-start yung intersection or diyan magkaroon ng tangency, yung straight line and the curve. Okay? Then for the point of tangency, the point of tangency is the point of the forward tangent where the curve ends. So this is the forward tangent. Dito nag-i-end yung curve natin. So designated as PT. Okay? Pwede rin siyang tawagin EC, end of curve, or CT or curve to tangent. Okay? So please be notified with our orientation para hindi tayo malito. Next would be the central angle. So the central angle is the angle formed by two radii drawn from the center of the circle to the PC and PT. The value of the central angle is equal to the angle I. Some authorities call both the intersecting angle and sectoral angle either I or A. Okay. So this is your central angle from this radius here to this radius here. Okay. And sometimes we call that delta, delta, or that is also equivalent to I. Take note that the angle here is also the same as the angle here, the angle of deflection. Okay? So parehas sila. So point of curve. The point of curve is any point along the curve. So any point along the curve. So depende kung saan yung i-specify. So pwedeng dito, pwedeng dito, pwedeng dito, okay? So yan. Next would be the length of the curve. The length of the curve is the distance from the PC to the PT measured along the curve. Okay? Don't be confused. The length of the curve is yung mismong length nitong curve na to. This is the length of the curve. Now, the length of the chord. Okay? Ano yung length of the chord? Define natin. Or length of the chord or long chord. So, the long chord is the straight line distance between the PC and the PT. Other types of chord are designated as follow. C for full chord distance between the adjacent station, full, half, quarter, or 1/10 station. C sub 1, chord distance between PC and the first station on the curve. C sub 2, sub chord distance between the last station and the first curve of the PT. So, ano ba yung long chord? This is the long chord, okay? Ito yung long chord natin. So, we have here the C sub 1 and we have here the C sub 2. So, meron kasi tayong tinatawag na full station. At this point, to the first full station, that is what we call the sub chord. So, we have here full station, full station, full station, and the last full station, then yung sub chord ulit before sa ating PT kasi hindi niya na-reach yung full station. Okay? So, okay, yan. So what is tangent distance? The tangent distance is the distance along the tangents from PI to PC or to the PT. The distances are equal on a simple curve. Since this is a simple curve, ito yung tinatawag nating tangent line. This is the tangent distance or the tangent line. Okay? The tangent here is equivalent to the tangent here if it is a simple curve. It is a compound curve, magkaiba na yan. Okay? So, and pag reverse curve, iba na rin yan. Okay? But, yeah. May magpaparehas pa rin pag inanalyze natin. Though we will explain that later. Okay? So, ayan. So, pag full station, it is capital D. Then, pag it is a sub chord or sub distance, it is D over it is small d2 and small d1. Okay? Wait, i-zoom out lang natin. Oops. Sobrahan. Okay. So, moving forward, next would be the external distance. So, the external distance or capital E is the external distance, also called as the external secant, is the distance from PI to the midpoint of the curve. The external distance bisect the interior angle of PI. Now, for the middle ordinate, it is the distance from the midpoint of the curve to the midpoint of the long chord. The extension of the middle ordinate bisects the central angle. So, ano ba yung external distance? So, yung external distance from the PI to the center of the chord. So, ito yung external distance natin. This is the E. Now, for the middle ordinate, it is from this point to this point. Okay? So, yan yung ating M, middle ordinate. Okay? Okay. Now, the degree of curvature. So, the degree of curvature defines the sharpness or the flatness of the curve. So, we will have an example of that later. Now, the degree of curvature, the last of the elements listed above, degree of curvature, deserves special attention. Why? Curvature may be expressed by simply stating the length of the radius of the curve. This was done earlier in the chapter when typical radii for various roads were cited. Stationing the radius is a common practice in land surveying and in the design of urban roads. For highway and railroad work, however, curvature is expressed by the degree of curve. Okay? So, two definitions are used for degree of curvature. These definitions are discussed in the following section. So, we have here the degree of curvature arc definition. So, the arc definition is the most frequently used in highway design. So, pag arc definition yan, most probably, ang gagawan natin ng design is a highway. Okay? This definition illustrated the following figure states that the degree of curvature is the central angle formed by the two radii that extends from the center to a circle that ends to an arc measuring 100 feet long or 100 meters long if you are using the metric units. Therefore, if you take a sharp curve mark of a portion so that the distance along the arc is exactly 100 feet, that and determine that the central angle is 12. The degree of angle is equivalent to 12 degrees. It is referred as a 12-degree curve. Okay? Now, yan. Okay? So, this is an arc of 100 feet. So, we have here our circumference because, yeah, ito yung circumference natin. Then, itong arc na to is 100 feet. Okay? No, 100 feet. 100-degree curve. And this is our degree of the curve. And we have here our radius. So, for a 1 degree, for a 1-degree curve, the radius is 5,729.58 feet. And the arc is equivalent to 100 degree. Okay? Or 100, no, 100 feet, sorry. Medyo malabo yung ano. Sorry. It is 100 feet. I repeat, for a 1-degree curve, the radius is 5,729.58 feet. And the arc is equivalent to 100 feet. Okay? So, the figure illustrates that the ratio between the degree of curvature, which is D, so ito, D is equivalent to 1 degree, and 60 degree is the same as the ratio between 100 feet of arc and the circumference C. Okay? So, of a circle having the same radius. This may be expressed as the degree of the curve per 360 degrees is equivalent to 100 feet per circumference. So, since the circumference of a circle is equivalent to 2 pi r, so C is 2 pi r, substitute natin. D is equivalent to 360 times 100 over 2 pi r. So if we're going to manipulate our equation, cross multiply, 360 degrees times 100 over 2 pi. The radius, therefore, is equivalent to 5,729.58 degrees per degree. This is the English system. Now, for the metric system, it is 1,145.916 per degree. So, gagamitin natin tong equations na to. Please memorize these two equations. This will become handy in the future. Okay? So, the degree of curve. So, chord definition. So, the chord definition is used in railway practice and in some highway works, but most often than not, it is being used for railway projects. So, this definition states that the degree of curve is the central angle formed by two radii from center of the circle to the end of a chord, 100 feet or 100 meter long. Take note, this time it is on the chord. Okay? So, if this is the simple curve, ito yung chord natin. So, that is 100. And the degree of curve is with respect to the chord, 100 feet. So, half of it, d over 2 is d over 2, and the length of the chord is 50 feet. Okay? So, same analysis per 7-degree curve, you have a radius of 5,729.65 feet per 100 feet chord. So if you take the flat curve mark, a 100-foot chord, and determine the central angle to be 30 minutes, then you have a 30-minute curve for the definition of the curve. So from observation of figure, you can see the following trigonometric relationship. Okay? So sine d over 2, sine d over 2 opposite over hypotenuse is equivalent to 50 over r. Then solving for r in English, okay? So cross multiply natin. R is equivalent to 50 over 1 half sine 1 half d. Okay? Now, for a metric system, it is R is equivalent to 10 over sine d over 2. So, memorize this formula, and please do not get confused if it is a chord, ano yan? We have the
um, we have the degree of curve, chord definition, yung formula sa baba. Then, for the degree of curve, arc definition, we have this. Okay, so please mark those formulas. Okay, so moving on. So what are the formulas for a curve? So we have here the tangent distance. Ito, tangent distance is equivalent to the radius times tangent theta over 2. Okay? Why? Because if you're take note, the pi, the point of tangency here and your radius are 90 degrees. So this is a right triangle. So opposite over adjacent. Okay? Opposite over adjacent. So tangent is equivalent to uh, opposite, which is t over r. So t therefore is equivalent to r tangent pi theta over, or not theta, delta over a. Okay. Next, for the chord distance, it is equivalent to c. Ito yung c natin. C is equivalent to 2r sine pi over 2. Bakit? Sine angle over 2 is equivalent to c over 2 times r. Okay? So, if we are to look for c, let's just manipulate our equation. Then, makukuha na natin si c. That is the distance for chord. So, sine function. Now, for the length of the curve, L over angle is equivalent to 2 pi r over 360 degrees. So L is equivalent to 2 pi r times the delta over 360. Now for the middle ordinate, we have M is equivalent to R times 1 minus cosine delta over 2. Now for the external distance, or the E, it is T tangent delta over 4, and that is also the same as R times 1 over cosine delta over 2 minus 1. So we will be using this equation. So we are now ready with our illustrative problem. So we have here problem number 1. The bearings of tangents has an angle of intersection of 141 degrees 23 minutes. If the degree of curve is 20 degrees for a chord distance of 20 meter, find the tangent distance. So this is a problem of a simple curve. So sa intersection ng tangent natin, so we have here the back tangent, and we also have here the forward tangent. Okay, the angle of intersection in between them is equivalent to 141 degrees 23 minutes. Okay, so let's try to draw our curve here. Yan. So try natin i-drawing yung curve. So this is a 90-degree curve. That is also a 90-degree curve. And more or less, ganito itsura ng aking simple curve. So that is how my simple curve would look like. Okay? And then according to the problem, the chord distance is 20 meter. Okay? So the chord distance is 20 meter. Okay? So this, if we are to bisect it, yan. If we are to bisect our curve, this is 10 meters. This is also 10 meters. The angle here, the angle of intersection, is the same as the angle here. Tama ba? So this is also 141 degrees 23 minutes. And since this is a simple curve, the tangent distance here is equivalent to the tangent distance here. Okay? So parehas lang sila. So there are two unknowns here. It would be the radius and the tangent. How did I say so? Take note, our unknown here is the tangent. So tangent is equivalent to, from our equation, radius tangent of I over 2. But here we do not know our value r. Okay? But we can solve our r using our equation. Equation for the chord method. Take note, we are given the chord distance here. So, ibig sabihin, we can use the chord definition. Okay? So, by chord definition, we can solve for the value of R. R is equivalent to 10 over, we have sine D over 2. Okay? And dito, given naman yung ating degree of the curve, which is equivalent to 20 degrees. And, yeah, given na. So, we can now solve for the radius. Tama? So, substituting the value, we are given 10 times sine times the degree of the angle. We have 20 over 2. And that is equivalent to 10 over sine 20 over 2. And that is equivalent to 57.59. Or let's use 3 decimal, 587 meters. Okay? And there's also another way of solving it because we are given the chord distance. Okay? Take note that the formula for chord distance is equivalent to 2 times r sine delta over 2. So if we are to substitute our given, we have c, which is equivalent to 20 times 2 times the radius times delta, which is equivalent to, pero yung delta na gagamitin natin is the degree of the curve. So that is 20 over 2. Now, if you're going to observe, we divide both side by 2 and sine theta to get r. So, pag imamanipulate mo lang itong equation na to, we will still arrive at the same equation. Okay? So, just para hindi lang kayo malito. So, pinakita ko lang na this equation is the same as this equation. So, makikita nyo itong equation na to sa handout nyo. Okay? Or sa module nyo. So, it should give us the same answer. So, we have here 20 is equivalent to 2 alpha x times sine 20 over 2. And that is equivalent to 57. Okay? So, 57.588. 588 meters. So, this is also 88 meter rather. Okay? So, the next thing we need to solve, or we can now solve with our tangent. So, tangent is equivalent to r tangent I over 2. So, that is equivalent to, what is the radius? 57.588 tangent. What is the angle here? We have 141 degrees, 23 minutes over 2. So, the tangent distance is equivalent to times tangent 141.23 over 2. That is equivalent to 164.368 meters. So that is the tangent distance there. Okay? Okay, so we have here number 2, the azimuth of the back and the forward tangent of a simple curve, respectively r. Okay, so we have here the azimuth of the back tangent. So, unahin natin si back tangent. So, it is 220 degrees. So, 100 plus 40. So, more or less, nandito yung ating backward tangent. Okay. Then, sabihin natin na nandito yung ating point of intersection. Now, for the forward tangent, it is for 257. So, 190, 180, 270. So, nandito pa rin siya. Nasa third quadrant siya. Okay? So, let's say this is the back tangent. So, yeah. Okay, so lagay natin yung ating azimuth here. We have 220 degrees, 45 minutes. And dito, we have 257 degrees, 25 minutes. A line with a bearing of intersects with the forward tangent at point 32 meters from the vertex. Okay, but before that, let's try to draw first, no? Let's try to draw our curve. Okay, so maybe this is the center. Okay, so pagdugtungin na natin yung ating. Yun. So that is our simple curve. Now this would be my point of curvature. This is my point of tangency. This is the vertex. Okay. Okay. So we have here a line with the bearing of a north 32 degrees 42 going east intersects the forward tangent. So this is the forward tangent at a point 35.2 meter from the vertex. So let's say this is the 35.2 meter from the vertex. So this is 35.20 meter from the vertex. Okay. Then magkakaroon tayo dito ng angle bearing. Okay? So may bearing tayo dyan. But let's continue to read. A line with bearing north, take note it is from north going east, intersects the forward tangent at point dito. So dito mag-intersect from the vertex, so tama, from the vertex of the simple curve and the simple curve at point Z. Okay, so let's say dito is point Z. Point Z is a point along the curve. So ibig sabihin, yung intersection natin would be here. Medyo malayo. Ito. To be more realistic. Yan. So, let's say, okay. And the bearing of this, the bearing is equivalent to 42. 32. So, 32 degrees, 42 minutes. So, at point, this is point Z, and ito yung bearing niya, nag-intersect yung line with a point 35.2 meter from the vertex. Okay? So, magkakaroon din tayo ng another angle. Let's say it is alpha. So, if the simple curve, or if the middle ordinate rather, of the simple curve is 9.7 meters, and the stationing of V is at station. Okay? So, yung V natin, station V is at 50 plus 143. What would be the stationing of point Z? Okay, so ano yung magiging station ng point Z natin? And PT, determine the other elements of the simple curve as well. So use the arc definition. So since we have the stationing of B, we are going to subtract the tangent. Then from the tangent, we're going to add the distance from PC to Z and the distance of the curve. Okay, so what are the given? We are given M is equivalent to 9.70 meters. And we also have, station V, which is 50 plus 143. And we are to determine the station here. Station PC and station Z. Kasi babalik tayo. So, PC, Z, and station PT. Okay? So, unahin natin isolve si I. Why? Because we are given here the two azimuth. So if that would be that would be the backward azimuth and the forward azimuth. So forward azimuth minus the backward azimuth would give us the I. Okay? So I here is equivalent to 257 degrees 25 minutes minus 220 degrees 45 minutes. Therefore, I is equivalent to 257 25 minus 220 45. And that is equivalent to 36 degrees 40 minutes. So we already have our I. So what can we solve next, no? Take note, we are given the middle ordinate. So if we are going back to our equation for the middle ordinate, we can solve R because M is equivalent to R times 1 minus cosine I over 2. Okay? Okay, so the next thing is to substitute the value. By the way, yung angle delta dito is not the degree of the curve. It is the angle here. Okay? So substituting the values, we have the radius to be ilan yung radius natin? Unknown. Unknown pala. So we have the middle ordinate of 9.7 times r. 1 minus cosine of 36 degrees 40 minutes divided by 2. So r therefore is equivalent to 9.7 is equivalent to alpha x times 1 minus cosine 36 degrees 40 minutes divided by 2. Okay? Shift solve. Therefore, our radius is equivalent to 191.105 meters. Okay? We can also solve for t. Okay? So, take note of the formula for t. For the tangent, tangent is equivalent to r times tangent of I over 2. So substituting the value, we have 191.105 tangent of 36 degrees 40 minutes over 2. Therefore, the tangent distance is equivalent to 191.105 tangent 3640 over 2. And that is equivalent to 63.325 meter. Okay? So in order for us to solve for the length of the curve, from PC to point Z, we need to determine the angle. Okay? So let's try to draw here a point from Z to the center of the radius. Okay? So kailangan natin malaman yung angle dito so that we can determine the length of the curve from this point to this point. So how are we going to do that? So first is we have here the distance from the vertex 35.2 meter going to the PT. Okay, so lagyan din natin ng line dyan. Then we can have here a beta, angle beta. Then yung angle na nag-create from the tangent from the point Z and yung forward tangent natin, magkakaroon tayo ng angle lambda. Then, pag meron na tayong angle lambda and angle beta, we can subtract that to 180 degrees so we can have our angle here. Then using a sine law or cosine law, we can solve for the angle here. So let's say this is alpha and let's say this is angle theta. Okay? So, isa-isahin natin. Here we have the distance. This distance is our radius. Take note, it is the radius. And our tangent here is equivalent to 63.325 from this point to this point minus 35.2. So if we are to redraw the triangle, i-redraw natin itong triangle natin so we will not be confused. Okay? So make sure they are parallel. Okay? Yan. So let's say this is theta. The angle here would be beta. And the distance here would be the radius, which is 191.105. And this distance here is equivalent to, yan. So that is equivalent to 63.325 minus 35.2 meters. So that is 35.2 meters. Okay? So we have two known sides. We can use, wait, let's check. We can use, no, it's not it is not sine law, it is not cosine law. Why? Because this is a right triangle. Okay? So, ibig sabihin, this is hypotenuse. So, we can solve angle theta here using tangent, opposite over adjacent. Take note, this is hypotenuse. This is 90 degrees. So, opposite over adjacent. So, tangent theta is equivalent to 63.325 minus 35.2 divided by 191.105. Theta therefore is equivalent to shift tangent 63.325 minus 35.2 over 191.105. And that is equivalent to 8.372 degrees, or that is equivalent to 8 degrees 22 minutes 19.72 seconds. Okay, so there we can now solve for beta. So beta is equivalent to 180 degrees because the interior angle is 180 degrees minus 90 degrees minus 8 degrees 22 minutes 19.72 seconds. Therefore, beta is equivalent to 180 minus 90 minus 8 degrees 22 minutes 19.72 seconds. And that is equivalent to 81 degrees 37 minutes 40.28 minutes. Okay? Next is si alpha. Take note, pag meron na tayong alpha, we can now determine this angle. So let's say this is angle angle rho. So this is angle rho, then sabihin natin this is angle gamma. Okay? So angle gamma. So unahin natin si angle alpha. So in order to solve for angle alpha, take note that the azimuth of this line, of this tangent, is 257 degrees. So 257 degrees minus the bearing of this line, of this tangency here. And that is 32 degrees 42 minutes. So 257 degrees 25 minutes minus 180 degrees minus the bearing, that would give us the angle alpha. Okay? So angle alpha is equivalent to 257 degrees 25 minutes minus 180 degrees minus 32. The bearing is 32.42. So 32 degrees 42 minutes. Therefore, angle alpha here is equivalent to 257.25 minus 180 minus 32.42. and that is equivalent to 44 degrees 43 minutes. So that is angle alpha. So we can now solve for angle rho. So angle rho is equivalent to, take note, this is 180 degrees minus alpha minus beta. And we are left with angle rho. So we have here 180 minus 81 degrees 37 minutes 40.28 seconds minus 44 minutes and 44 degrees and 43 minutes. So we are left with what value? 53. So 53 degrees 39 minutes 19.72 seconds. So that is the value of rho. Okay? So pwede na natin tignan itong triangle na to. But take note, we only have angle rho for this. So pwede nating dagdagan because take note, this is a right triangle here. We can solve for the hypotenuse. So we will be having one side and one angle. Okay? Then let's see where we can head from there. Okay, so niredraw ko siya. So after redrawing that, take note this is, we can solve this the hypotenuse. Let's say this is point X here, and this is our center. So we can solve distance XO. So distance XO is equivalent to what function? We can have it either sine or we can have it cosine. So para maging safe, since we already know the radius here, and the radius is here 191, or pwede rin naman, pwede rin naman ito sine function. So it's up to you. But you should have generate the same answer. So using cosine function, cosine theta. What is theta? Cosine theta, which is 8 degrees 22 minutes 19.72 seconds. Cosine theta is equivalent to the adjacent over the hypotenuse. So times the radius. And our radius is 191.105. Okay? Adjacent over hypotenuse. Therefore, distance XO is equivalent to 191.105 cosine 8 degrees 22 minutes 19.72 seconds. And that is equivalent to 189.068 meters. Okay? So alam na natin tong distance na to. This is 189.068. Okay? Take note, the point Z here is still on the curve. Therefore, itong distance na to, this is still radius. Okay? And the radius is equivalent to 191.105 meter. Okay? And this is angle, let's say, phi. Okay? So, angle phi. Okay, so next na hahanapin natin would be gamma. Why? Because if we're going right away with the phi, we do not know the angle phi and we do not know side opposite to the angle phi. So we need to solve first for the angle gamma here. So may it be sine or cosine law. But using sine law, we can solve for gamma. So we have here 191.105 over sine of 53 degrees 39 minutes 19.72 seconds is equivalent to, we have the side here of 189.068 sine gamma. Okay? So cross multiply, sine gamma is equivalent to 189.068 sine 53 degrees 39 minutes minutes, 19.72 seconds divided by 191.105. Okay, get the arc sine. Gamma is equivalent to, so arc sine of 189.068 sine 53 degrees, 39 minutes, 19.72 seconds divided by 191.105. And that is equivalent to 52.833 degrees, or that is equivalent to 52 degrees, 50 minutes, 0.32 seconds. So that is angle gamma. So we can now solve for angle phi because the interior angle of a right triangle is 180 degrees. So solving for phi, phi is equivalent to 180 minus rho. What is rho? Angle rho here is 53 degrees. 53 degrees, 39 minutes, 19.72 seconds, minus angle gamma, which is 52 degrees, 50 minutes, and 0.32 seconds. Okay? Therefore, angle phi is equivalent to 180 minus 53 degrees, 39 minutes, 19.72 seconds, minus 52 degrees, 50 minutes, 0.32 seconds. And that is equivalent to 73 degrees, 30 minutes, 39.96 seconds. Okay? But we have a problem here. Why? Because 73 degrees is greater than our I. Take note that the total angle here from the radius or from the PC to the PT is only 36 degrees 40 minutes. So it is greater than 34 degree no. It is greater than 36 degrees 40 minutes. So inconsistent siya. Okay? So this is incorrect therefore. And if you're going to check the figure, maliit lang siya. Maliit lang yung angle na nandyan. So ang gagawin natin is to recall our trigo function. Okay? So from trigonometry, from trigo function, isn't it that for the functions of the angle, we have here sine 180 minus gamma, or sabi natin gamma, diretso na tayo. 180 minus gamma is equivalent to sine gamma. Okay? So if we are to have that, basing it sa problem natin, we have sine gamma is equivalent to sine 180 minus gamma, and that is equivalent to, babalik tayo dito. Okay, so balikan natin to. We have here gamma is equivalent to arc sine of 189.068 sine 53 degrees 39 minutes 19.72 seconds divided by 191.105. So gamma is equivalent to, so that is equivalent to 189.068 sine 53 degrees 39 minutes 19.72 seconds divided by 191.105. And that is equivalent to, wait. Okay, so may mali. Bakit? Take note dito, this one here is the radius and this one here is beyond the radius. So dapat mas mahaba itong distance nito compared sa radius. And this is incorrect. It is not 189. Okay? So for that, we have here the it is cosine theta is equivalent to r over xo. Baliktad yung equation natin. So, baliktad yung equation. It is cosine 8 degrees, 22 minutes, 19.72 is equivalent to the adjacent side, which is the radius. Ang radius natin is 191.105 over XO. Therefore, XO is equivalent to, it should be a division, not multiplication, no? So, 191.105 divided by cosine 8 degrees, 22 minutes, 19.72 seconds. And that is equivalent to 193.163 meters. So, that is line XO. So, palitan din natin ito. This should be 193.163. So, yeah. 193.163 times sine 53 degrees, 39 minutes, 19.72 seconds divided by 191.105. And that is equivalent to this is equivalent to 193.163. So this is arc sine of 814. Okay? Tapos etong angle natin, this should not be 52. It is equivalent to arc sine 193.163 sine 53 degrees 39 tapos 19.72 divided by, wait, nasobrahan. Okay, 191.105. That is 54 degrees, 30 minutes, 9.43 seconds. So this is minus 54, 30, 9.43. So the correct angle is, so times negative 1 minus 53, 39, 19.72 plus 180. 71. Anyhow, it is still bigger, no? Mas malaki pa rin siya. Okay. So, that's it. So, we have gamma here as arc sine of 0.814. So, ibig sabihin, sine gamma is equivalent to 0.814. Okay? Substitute natin si sine gamma dito. So, matitira, we have here sine 180 minus gamma is equivalent to sine gamma, and sine gamma is equivalent to 0.814. Okay? So, arc sine 180 minus gamma is equivalent to arc sine of 0.814. Okay? Therefore, transposing gamma to the other side of the equation and this to the other side of the equation to make things positive. Okay? So, gamma is equivalent to 180 degrees minus what is arc sine of gamma. Take note that arc sine of gamma is equivalent to 54 degrees. Okay? Arc sine of gamma ito. Tama? So, arc sine of gamma is equivalent to 54 degrees, 30 minutes, 9.43 seconds. Therefore, the true value of gamma is equivalent to 180 degrees minus 54 degrees, 30 minutes, and 9.43 seconds. And that is equivalent to 125 degrees, 29 minutes, 50.57 degrees. So this is the true value of gamma. So from there, we can now solve for the value of phi. Okay? So for the value of phi, it is 180 degrees minus gamma minus, ano ba isa nating sign? Minus rho. So we have 180 degrees minus 125 degrees, 29 minutes, 50.57 seconds minus the value of the rho. And yung rho natin is 53 minutes, 39 seconds, 19.72 seconds. Therefore, phi is equivalent to it is equivalent to 0 degrees, 54 minutes, 49.71 seconds. So this is the true value of phi. So since we already have our phi, meron na tayo dito na uh, theta, meron na tayong phi, pwede na natin malaman yung angle dito. Okay? Let's say that this is angle psi. Okay? So for angle psi, it is equivalent to I minus phi minus theta. So what is the value of I? I here is equivalent to 36. So 36 degrees, 40 minutes minus theta. And yung theta natin is 54 minutes. And if i-base natin siya sa figure, fit siya. So this is correct answer. So minus 54 minutes, 54 minutes and 49.71 seconds. Minus theta, and the value of our theta is equivalent to 8 minutes, 22 degrees, 19.72 seconds. So the value of psi therefore is equivalent to 36, 40 minus 54 degrees, and 0 degrees, 54 minutes, and 49.71 seconds. Minus 8 degrees, 22 minutes, 19.72 seconds. And that is equivalent to 27 degrees, 22 minutes, 50.57 seconds. So we can now solve for our distance or length of curve PC2 point Z. Now for the length of the curve, from point PC to Z, we are given the formula of 2 pi r divided by 360 degrees times I. But on this case, it is psi. Okay? On this case, it is psi. So, we have 2 times pi times the radius of 191.105. Ayusin lang natin. Yan. Times, what is psi? Psi here is equivalent to 27. So 27 degrees, 22 minutes, 50.57 seconds divided by 360 degrees. Therefore, the length from PC to Z is equivalent to Okay. That is equivalent to 91. So 91.326 meters. Okay? So that is the length of PC to Z. So anong pinapahanap sa atin? We are to determine the stationing of point Z. So the stationing of point Z is equivalent to, unahin muna natin, station of PC. So station of PC is equivalent to station of V minus tangent. So what is the station at V? The station at V is equivalent to 50 minus 143. So ang basa dito, class, is 50,000 is 50 kilometers and 143 meters. Okay? So ilan thousand meters ba ang 50 kilometers? It is 50,000 meters. So 50,143 meters. Yan ang basa dyan. But we can also read it as 50 plus 143. Okay? So, minus the tangent. Ano yung tangent natin? The tangent is 63.325. Therefore, station PC is equivalent to 143 minus 63.325. That is equivalent to 50 plus 079.675. What if ganito yung value? If it is 50, if it is 143 minus 207. So that is greater. So ang gagawin natin, 50, 143 minus 207. Then it would be 49 plus 936. Ganon yung magiging outcome. Okay? Okay, so this is the station of the PC. Now for the station of Z, so station of Z, it is station of PC plus the length from PC to Z. So the station at PC is 50 plus 079.675 plus length of PC to Z, that is equivalent to 91.326. Therefore, station Z is equivalent to 79.675 plus 91.326. That is equivalent to 50 plus 171.001. So that is the station of Z. Now for the station of PT. So station, okay, iwalay lang natin. So we have here station of station PT. It is equivalent to station Z, station PT, PC, station PC plus the length of the curve. So for the L is equivalent to 2 pi times R divided by 360 times I. And that is equivalent to 2 times pi times the radius of 191.105 divided by 360 degrees times I. What is I? 36 degrees 40 minutes. L therefore is equivalent to 2 pi 2 times pi times 191.105 over 360 times 3640. And that is equivalent to, no, it's not an angle. So that is equivalent to 122.298 meters. Therefore, station PT is equivalent to 50 plus 171.001 plus 122.298. Therefore, station PT is equivalent to 171.001 plus 122.298. So that is equivalent to 50 plus 293.299. So that is the station of PT. Okay, ano pa bang pinapahanap sa atin? So we are to solve for the elements of the simple curve. You can also use pala, by the way, yung etong formula na to for L. You can also use the formula L is equivalent to 20 times I over D. Okay? So, yeah. Pwede nyo rin gamitin yan. Okay, so next we have to determine the E. So, E is equivalent to R times secant I over 2 minus 1. So, the radius is 191.105 times secant of I over 2 minus 1. And that is equivalent to 10.219 meters. Next, for the length of the chord, that is equivalent to 2r sine of I over 2. Okay? So we have here 2 times 191.105 sine of 36 degrees 40 minutes over 2. And that is equivalent to 2 times 191.105 sine 3640 over 2. And that is equivalent to 120.222 meters. Okay, and that's it for number 2. Okay, number 3, the offset distance of simple curve from the PT to the tangent line passing through the PC is equal to 120 meter. The stationing of PC at 2 plus 540.26. The simple curve has an angle of intersection of 50 degrees. So since it is a simple curve, let us first draw our simple curve. Okay, so this is the forward tangent, this is the back tangent. The angle of intersection has an angle of 50 degrees. So let's say this is the center of the circle. Yeah, so that is our radius. Okay, so connecting, we have here our simple curve. Okay, so ano pang ibang given? Let's try to extend this. Okay, so the offset distance of the simple curve from the PT to the tangent line passing through PC. Tangent line passing through PC. So ito yon, from the PT. So PC, then we have here PT is equivalent to 120. So this is 120 meters. Okay. And the stationing of PC is equivalent to 2 plus 540.26. The simple curve has an angle of 50 degrees. So first is compute the degree of the curve. So to solve for the degree of the curve, we need to have the radius. So the degree of the curve, assuming, no, since it is not stated, we are going to use the arc definition. So we have here the degree of the curve is 1145.916 divided by the radius. But we do not know our radius yet. Okay? So we can solve for the radius using another equation for the tangent. So tangent is equivalent to r times tangent of I over 2. But we do not know our tangent yet. So we need to solve for the tangent. Take note that this one, etong line na to, this is also tangent. Tama ba? And we are given here a distance of 120 meters and an angle of 50 degrees. Okay? So using sine function or sine function, yeah, opposite over hypotenuse. And our hypotenuse here is the tangent distance. So sine 50 degrees is equivalent to opposite side, which is 120, divided by the hypotenuse of t. T therefore is equivalent to 120 divided by sine 50. And that is equivalent to 120 over sine 50. So 156.649 meters. So that is the value of the tangent. Okay? Tapos, next, we can now solve for the r. So, r is equivalent to divide both sides by tangent I over 2. So, r is equivalent to t divided by tangent I over 2. T is equivalent to 156.649 divided by tangent of what is our interior angle or the angle of intersection. It is 50 over 2. Radius therefore is equivalent to 1 point wait. It is equivalent to 335.935 meters. So we now have our radius here. So we can now solve for our d. Okay. So d is equivalent to 1145.916. I repeat, this is arc definition in the metric system divided by the radius of 335.935. Therefore, the angle is 3.411 degrees. Okay? Or pwede rin namang 3 degrees, 24 minutes, 40.05 seconds. Next, compute for the external distance. Now, for the external distance, E is equivalent to R times secant I over 2 minus 1. So substituting the value, the radius is 335.935 times secant over times I. What is I? 50. 50 over 2 minus 1. Take note, secant is the inverse of 1 over cosine. Okay? So 335.935 times 1 over cosine 50 over 2 minus 1. And that is equivalent to 34.728 meters. So that is the external distance. And lastly, compute for the length of the curve. For the length of the curve, curve. Okay. So for the length of the curve, it is 20 times I divided by D. It is 20 times 50 over the degree of the curve. That is 3 degrees, 24 minutes, 40.05 seconds. So the degree of the curve is 20 times 50 over 3 degrees, 24 minutes, 40.05 seconds. So that is equivalent to 293.158 meters. Okay?
Next is a compound curve. So a compound curve consists of two or more circular curves
or simple curves, two main tangents joined at point of compound curve. So you have the PCC of or point of compound curve. So curve at PC is designated as 1 and the curve at PT is designated at 2. Okay, so dito we are combining two simple curves. Okay, so the point o yung PI na natin, same pa rin, it is the tangent 1 and tangent 2. Now, tangent tangent 1 plus x, then tangent 2 plus y, rather. Okay? Then, yung tangent 1 for this curve 1 is the same. Parehas yung tangent 1 dito sa tangent 1 dito. That is for curve 1. Now, for curve 2, the tangent 2 here is the same as the tangent 2 here. Okay? So, the interior angle here is still the same as the deflection angle here. The interior angle of the second curve is the same as the angle here. Okay, and the deflection angle on the point of intersection is I1 plus I2. So it is still the same. So we're going to add the interior angles of these two curve. Okay, so we have the vertex 1, we have the vertex 2. The PCC is the point of the compound curve. So it is where the points of your compound curve will be meeting the end of compound curve, the end of simple curve 1 and the start of the simple curve 2. That is your PCC. Okay, so we have here distance x and distance y. So here we can generate a triangle. Okay, so the elements of a compound curve, PC, point of curvature, PT is point of tangency, PI is the point of intersection, PCC is the point of compound curve, T1 is the length of tangent on the first curve, ito yon. T2 is the length of the tangent on the second curve, ito rin yon. V1 is the vertex of the first curve, V2 is the vertex of the second curve, I1 is the central angle of the first curve, and I2 is the central angle of the second curve. I is the angle intersection, which is I1 plus I2. LC1 is the length of the first curve. LC2 is the length of the second curve. Okay, L1 is the length of the first chord, and L2 is the length of the second chord. L is the length of the long chord from PC to PT. T1 and T2 are tangent of the common tangent, length of the common tangent measured from V1 to V2. So, yung tinutukoy na V1 and V2, ito yon. So, T1, T2. Okay? Then, theta is equivalent to 180 degrees minus I. What is the theta? It is I1 minus I2, I180 minus I1 minus I2. Then, we can generate our theta. Okay? Next would be x and y can be found from the triangle. So we can solve that. And L can be found from the triangle as well. So stationing of the PC, the station of PT rather, the stationing of PT is equivalent to station of the PC plus LC1 plus LC2. Station of PT is equivalent to P1 minus a PI minus X plus T1 plus LC1 and LC2. Okay, so we can now proceed with our illustrative problems. Okay, so we have here two simple curves having angles of intersection of the tangents equal to 36 and 68 degrees in 45 minutes, respectively, are joined to form a compound curve, where the PT of the first curve becomes the PCC of the compound curve. Okay, so let's say, ito yung ating curve. Okay, then the length, okay, then dito yung ating PCC. Yan. The length of the first curve is 427, while the length of the second curve is 235. Okay? So, assuming ito yung itsura niya. So this is R1, this is R2, and this is PCC, this is PCC, and we have here your PT. Okay, the intersecting angle for the first simple curve is 36 degrees, while the second curve is 68. So 68 degrees 45 minutes. Okay? So we are to find the length of the chord. Palitan natin to. This is the length of the chord. Because if it is the length of the curve alone, ipag-add lang natin yung dalawang distance or dalawang length. So 427 and 325. Okay? So find the length of the chord from the PC to the new compound curve. So we are to determine this distance. Okay? The length of the chord. So how are we going to do that? We need first to solve the length of the chord of the first tangent and the length of the chord of the first simple curve. Then from there we can now solve our we can now solve the length of the chord from the PC to the PT of the compound curve. The length of the chord can be given by the equation. It can be LC or it can be C, is equivalent to 2R sine I over 2. So from there, we can get our C. But we cannot yet proceed solving for C because I do not have my R yet. So first, I need to solve my R. Now, what equation will give me the value of R given na ito yung mga given natin? Okay, it would be the length of the curve. So the length of the curve is equivalent to 2 pi r divided by 360 degrees times I. Okay? So L1 here is equivalent to 427. So 427.14 meters is equivalent to 2 pi R1 over 360 degrees times I. What is I1? That is 36 degrees. Okay? Therefore, R1 is equivalent to 427.14 is equivalent to 2 times pi times 36 divided by 360. Shift solve. Wala yung x times alpha x. Therefore, radius 1 is equivalent to 79.814 meters. Okay? Then I can now solve for C1. Okay? So, C1 is equivalent to 2 times 679.814 times sine 36 divided by 2. C1 therefore is equivalent to 679.814 sine of 36 divided by 2. That is equivalent to 420.148 meters. Okay? Next, solve natin si R2. Okay? So we have here L2 is equivalent to 2 pi r divided by 360 times I. So substituting, we have 235. 235.21 is equivalent to 2 pi times the radius of R2, which is 360 times 68 degrees 45 minutes. Therefore, R2 is equivalent to 2 times pi times alpha x times 68 degrees 45 minutes divided by 360. And that is equivalent to 196.022 meters. Okay. So next, we can now solve for our C2. C2 is equivalent to 2 times 196.022 sine of 68 degrees 45 minutes over 2. So times 2 times sine of 68 45 over 2. It is equivalent to 221.351 meters. So meron na tayong values nito. Okay? Next, we need to get the angle at the PC. Okay? Or PCC rather. Then we can now use cosine law. Okay? So take note, this is radius 1. This is also radius 1. Therefore, the angle here and the angle here would be the same. Okay? So if we are to bisect it, no, if iba-bisect natin to, parehas lang symmetrical. So the angle here and the angle here would be the same. Likewise for this curve, the angle here and the angle here, the radius here and the radius here are the same. And pag gagawa tayo ng triangle, yung angle dito and angle dito are the same. Okay? So to get the angle at PCC, okay? So angle at PCC, that is equivalent to, so 180 degrees minus 36 degrees divided by 2, because the interior angle of a right triangle is 180 degrees minus 36 degrees divided by 2, makukuha natin to. Okay? Kasi dalawa sila. Plus another 180 degrees minus 68 degrees 45 minutes divided by 2. 180 degrees for the interior angle minus 68 degrees divided by 2 to get the angle here. Therefore, theta PCC is equivalent to 180 minus 36 over 2 plus 180 minus 68 degrees 45 minutes over 2. And that is equivalent to 127 degrees 37 minutes and 30 seconds. So we can now use cosine law. Okay, take note, we are looking for the new length of the chord. Okay, so for the new length of the chord, LC is equivalent to the square root of the two sides. The squared property of the two sides, which is 420.148 squared plus 221.351 squared minus 2 times 420.148 times 221.351 cosine of 127 degrees 37 minutes and 30 seconds. Okay? Therefore, LC is equivalent to 420 degrees, 420.148 squared plus 221 point, tama ba? Yes, 221.351 squared minus 2 times 420.148 times 221.351 cosine 127 degrees 37 minutes and 30 seconds. Therefore, LC is equivalent to 582.299 meters. Okay? Okay, so we have here two simple curves having angles of intersection of the tangents equal to 36 and 68 degrees and 45 minutes, respectively, are joined to form a compound curve, where the PT of the first curve becomes the PCC of the compound curve. Okay? So let's say, ito yung ating curve. Okay. Then, the length, okay, then dito yung ating PCC. Yan. The length of the first curve is 427, while the length of the second curve is 235. Okay? So, assuming ito yung itsura niya. So, this is R1, this is R2, and this is PCC, this is PCC, and we have here your PT. Okay, the intersecting angle for the first simple curve is 36 degrees, while the second curve is 68. So 68 degrees 45 minutes. Okay? So we are to find the length of the chord. Palitan natin to. This is the length of the chord. Because if it is the length of the curve alone, ipag-add lang natin yung dalawang distance or dalawang length. So 427 and 325. Okay? So find the length of the chord from the PC to the new compound curve. So we are to determine this distance. Okay? The length of the chord. So how are we going to do that? We need first to solve the length of the chord of the first tangent and the length of the chord of the first simple curve. Then from there we can now solve our we can now solve the length of the chord from the PC to the PT of the compound curve. The length of the chord can be given by the equation. It can be LC or it can be C, is equivalent to 2R sine I over 2. So from there, we can get our C. But we cannot yet proceed solving for C because I do not have my R yet. So first, I need to solve my R. Now, what equation will give me the value of R given na ito yung mga given natin? Okay, it would be the length of the curve. So the length of the curve is equivalent to 2 pi r divided by 360 degrees times I. Okay? So L1 here is equivalent to 427. So 427.14 meters is equivalent to 2 pi R1 over 360 degrees times I. What is I1? That is 36 degrees. Okay? Therefore, R1 is equivalent to 427.14 is equivalent to 2 times pi times 36 divided by 360. Shift solve. Wala yung x times alpha x. Therefore, radius 1 is equivalent to 79.814 meters. Okay? Then I can now solve for C1. Okay? So, C1 is equivalent to 2 times 679.814 times sine 36 divided by 2. C1 therefore is equivalent to 679.814 sine of 36 divided by 2. That is equivalent to 420.148 meters. Okay? Next, solve natin si R2. Okay? So we have here L2 is equivalent to 2 pi r divided by 360 times I. So substituting, we have 235. 235.21 is equivalent to 2 pi times the radius of R2, which is 360 times 68 degrees 45 minutes. Therefore, R2 is equivalent to 2 times pi times alpha x times 68 degrees 45 minutes divided by 360. And that is equivalent to 196.022 meters. Okay. So, next, we can now solve for our C2. C2 is equivalent to 2 times 196.022 sine of 68 degrees 45 minutes over 2. So, times 2 times sine of 68 45 over 2. It is equivalent to 221.351 meters. So, meron na tayong values nito. Okay? Next, we need to get the angle at the PC. Okay? Or PCC rather. Then, we can now use cosine law. Okay? So, take note, this is radius 1. This is also radius 1. Therefore, the angle here and the angle here would be the same. Okay? So, if we are to bisect it, no, if ibabisect natin to, parehas lang symmetrical. So, the angle here and the angle here would be the same. Likewise, for this curve, the angle here and the angle here, the radius here and the radius here are the same. And pag gagawa tayo ng triangle, yung angle dito and angle dito are the same. Okay? So, to get the angle at PCC, okay, so angle at PCC, that is equivalent to, so 180 degrees minus 36 degrees divided by 2, because the interior angle of a right triangle is 180 degrees minus 36 degrees divided by 2, makukuha natin to. Okay? Kasi dalawa sila. Plus, another 180 degrees minus 68 degrees 45 minutes divided by 2. 180 degrees for the interior angle minus 68 degrees divided by 2 to get the angle here. Therefore, theta PCC is equivalent to 180 minus 36 over 2 plus 180 minus 68 degrees 45 minutes over 2. And that is equivalent to 127 degrees 37 minutes and 30 seconds. So we can now use cosine law. Okay, take note, we are looking for the new length of the chord. Okay, so for the new length of the chord, LC is equivalent to the square root of the two sides. The squared property of the two sides, which is 420.148 squared plus 221.351 squared minus 2 times 420.148 times 221.351 cosine of 127 degrees 37 minutes and 30 seconds. Okay? Therefore, LC is equivalent to 420 degrees 420.148 squared plus 221 point, tama ba? Yes, 221.351 squared minus 2 times 420.148 times 221.351 cosine 127 degrees 37 minutes and 30 seconds. Therefore, LC is equivalent to 582.299 meters. Okay? Okay, so for the last problem on compound curve, balikan natin si problem number 4. So, here we already have our radius. Okay? Ang radius natin dito, r is equivalent to 381.973. Then dito, ang radius natin is 229.184 meters. Then the tangent here, tangent 1 is equivalent to 105.931 meters. And the tangent here is equivalent to 74.466 meters. And t here is equivalent to 180.397 meters. So here, we need to compute for the station of the PC. Okay, so two tangents intersect at station 26 plus 050. So vertex is equivalent to 26 plus 050. A compound curve live on the grade on their tangents has the following data. So ito na yun. So they are just the same. Okay, so na-solve na natin siya. So what we're going to do, we have here our station. We are given the station of the vertex, which is 26 plus 26 plus 050. So what we're going to do is isusubtract natin tong distance na to. Then from here, i-add natin yung length of the curve to get the station of the PT. So V, so station of the station PC is V minus this distance. Then station of PT, PC plus this plus the length of the curve. Okay. So before we can do that, we need first to determine these distances. So let's say this is distance x, and this here is distance y. Okay? Isn't it that the interior angle here or the angle here is equivalent to the angle of intersection? So therefore, this is also 31 degrees. The angle here is also the same as the angle, the deflected angle here. So therefore, this is also 36 degrees. Okay? So let us confirm, no? So 180 degrees, the interior angle is 180 degrees. 180 minus 36 minus 31. So we have 180 minus 31 minus 36, that is 113 degrees. And take note, this is 180 degrees. So pag isusubtract natin si I, tignan natin, it is 180 minus 31 minus 36. So it will give us the same answer. Therefore, let's say this is theta. Theta is equivalent to 180 degrees minus 31 degrees minus 36 degrees. So that is equivalent to 113 degrees. So theta is 113 degrees. Okay, so what we need to do is to solve the distance x. Actually, we don't need to solve distance y because the PT will be in reference with, the station of PT will be in reference with PC plus the length of the curve. Okay, so station PC is equivalent to V minus X minus T1. Okay, solve natin si X. So we redraw our triangle. So we have it here. So we have here X, we have here Y. The angle here is 113 degrees. Then this distance here, T is equivalent to 180.397 meters. This is 31 degrees and this is also 33 degrees. So we are looking for this, so we can use sine law. So using sine law, we have 180.397 over sine 113 degrees is equivalent to distance x over sine 36. So x is equivalent to, we have 180.397 sine 36 divided by sine 113. And that is equivalent to 115.192 meters. Okay? So station PC is equivalent to the vertex 26 plus 050 minus distance x minus 115.192 minus T1, which is 105.931. Okay? So, station of PC is equivalent to. So, dito, magdi-decrease ito, definitely. So, gawin natin, 26,050 minus 115.192 minus 105.931. And that is equivalent to 25 plus 828.877. So, that is station PC. Now, for station PT, it is station PC plus the length of the curve. Okay? So, that is equivalent to, have we solved the length of the curve yet? So, wala pa. We need to solve for the length of the curve. So, L1 is equivalent to 2 pi R1 divided by 360 times I1. So that is equivalent to 2 pi times the radius 1, which is 391.973 over 360 times 31 degrees. And that is equivalent to 2 pi times 391.973 over 360 times 31. That is equivalent to 212.078 meters. Then L2 is equivalent to 2 pi R2 over 360 times I2. So that is 2 pi times, what is R2? Radius 2 is 229.184 divided by 360 times 36 degrees times 2 times 229.184 times 36 over 360. So that is 144.001 meters. So we can now do that. L1 plus L2. So station of the PC, we have 25 plus 828.877 plus 212.078 plus 144.001. Therefore, station of PT is equivalent to 25,828.877 plus 212.078 plus 144.001 is equivalent to 26 plus 184.956. So this is station P. Okay, so we have here number 8. Given the lines and direction as follows, AB is 57.6 meters. So this is A to B and it is due east. Then B to C is 91.5 meters. North, 68 degrees going east. It has a distance of 91.5 meters. And CD has an azimuth of 312. So if we will have our plane here, Cartesian plane, this is 312 degrees. Okay? A reverse curve is to connect these three lines, thus forming the center of a new road. So if we are to connect it by a reverse curve, ito yung magiging itsura niya. Compute the length of the common radius of the reverse curves. Okay? So ito yung tinatawag nating common radius. Okay? So it is the radius of radius of the first curve plus the radius of the second curve. Okay, so here, how are we going to do that? So the first thing that we need to consider is that to solve for the radius. Okay, to solve for the radius, we will be using the equation 1145.96 divided by d. But the problem here is we do not know our degree of curve. Okay, next equation that is available will be t. So t is equivalent to r tangent I over 2. Now there will be a relationship available. Why? Because take note, from B to C, it has a distance of 91.5. But B to C is tangent 1 plus tangent 2. Therefore, we can use this equation. So solving for tangent 1, we have the radius plus the tangent, the radius times the tangent of I1, which is 22 over 2. And T2 is equivalent to the radius tangent 64. This the angle here is 64 divided by 2. Now if we are to substitute this t1 and t2 of the equation here, that would become uh, that would become 91.5 is equivalent to r tangent 22 over 2 plus r tangent 64 over 2. Shift solve, then we can now have our common radius, and the common radius is 111.688 meters.
Lastly, we have the reversed curve. So reverse curve, though pleasing to the eye, would bring discomfort to motorists running at design speed. So the instant change in the direction, take note you're going to have a change of direction here. So from here going here. Okay? So nagkaroon tayo ng change of direction dito. So the PRC brought some safety problems. Despite this fact, reverse curves are being used with great success on park roads, formal path, waterway channels, and the like. Okay? So for reverse curve, you have here the PC, the point of curvature. You have your vertex 1, vertex 2, point of tangency. Then we have here our radius 1. We have here our length of chord 1. We have here our angle 1, angle 2, reverse 2. And PRC is point of reverse curve. Point of reverse curve. Yeah, tama. Okay, tama. Then we have here our common tangent. So tangent 1 plus tangent 2. That is our common tangent. Okay? So we have here our non-parallel reverse curves. So non-parallel, ibig sabihin, this back tangent is non-parallel to the forward tangent. Okay? Next would be a reverse curves for parallel tangent. What do you mean by that? The backward tangent is in parallel with the forward tangent. So kung titignan mo, parallel sila. Okay? Parallel yung tangents. And yeah. So for finding the stationing of the PT, so PT is equivalent station of PC plus LC1 plus LC2. Always remember that when looking for the stations, it is from PC, tapos yung length ng chord ang involved. If given si VI, V1, bumalik ka sa PC, then LC ang gamitin mo. Okay? Pag binigay naman si PRC2, then well and good, then proceed ka sa LC2. I-add mo si LC2. Always remember, it is the points that or the lengths that will be involved will always be the LC, length of the chord. Okay, so let's try our illustrative problems.
Okay, so we have here two parallel tangents 10 meter apart are connected by a reversed curve. So the chord length from the PC to PT is equivalent to 120. So first, we need to compute the length of the common tangent. Okay, so ito yung ating common tangent. So this is T1, this is T2. Okay, so let's say that is point A and this is point B here. Okay? So, the distance between these two parallel tangent, which is this tangent and this tangent, is 10 meters. It has a distance of 10 meters. Okay? So, the first thing that we can do or we can solve would be the I. Bakit? If we're going to see here, according to the problem, PC to PT is 120 meters. So from PC to PT, yan. From PC to PT, that is 120 meters. Okay? And the distance between this parallel and this parallel is 10 meters. So take note that the angle here, that the angle with the chord that makes with the tangent is equivalent to I over 2. So if we are to redraw that, it would look like this. Okay, so this is I over 2. This is 10 meters. And this is 120 meters. So we can solve using sine function. So sine I over 2 is equivalent to 10 over 120. So arc sine or I over 2 is equivalent to arc sine 10 over 120. I over 2 is equivalent to, we have arc sine 10 over 120 times 2. Okay? This is 4.78. I therefore is equivalent to 9 degrees, 33 minutes, 37.38 seconds. So this would be the value of I. So since we already have our I, we know that this one or the angle or the deflected angle here is equivalent to I. Okay? Since we have a parallel tangent here, the radius of the first curve is equivalent to the radius of the second curve. So the radius here is the same as the radius here. Therefore, the angle here is equivalent to the angle here. That is also I. Okay? This would also be equivalent to I. Okay? So, we can now solve for the length of the common tangent. So, for the length of the common tangent, that is AB. So, this is letter A. So, i-redraw natin yung triangle natin. Magmumukha siyang ganito. So, this is equivalent to this is equivalent to I, and this is equivalent to 10 meters. And this is now line AB. So line AB again is a sine function. So we have here sine I is equivalent to 10 over AB. Okay? Line AB is equivalent to 10 divided by sine 9 degrees, 33 minutes, 37.38 seconds. Therefore, line AB is equivalent to 10 sine 9 degrees, 33 minutes, 37.38 seconds. And that is equivalent to 60.209 meters. So we already have our common tangent. And that is equivalent to T. Okay? Okay. Next, compute or determine the equal radius of the reverse curve. So for letter B, we are to determine the radius So I repeat, since this is parallel, the I here is equivalent to the I here. Ibig sabihin, yung tangent dito ay equivalent din sa tangent dito. Therefore, T is equivalent to T1 plus T2. But T1 is equivalent to T2. Therefore, T is equivalent to 2T1 is equivalent to 2T2. Okay? Then, ang formula natin for tangent is T is equivalent to radius tangent I over 2. Okay? So, to solve for the radius, we have the tangent here. The tangent is equivalent to 60.209 divided by 2 is equivalent to tangent 1. So tangent 1 is equivalent to 60.209 divided by 2, 30.105 meters. Therefore, R is equivalent to divide both sides by tangent I over 2. So that is equivalent to T1 divided by tangent I over 2. And that is equivalent to 30.105 divided by tangent of I. What is I? 9. 9 degrees, 33 minutes, 37.38 seconds divided by 2. Therefore, radius is equivalent to tangent of 9 degrees, 33, 37.38 over 2. And that is equivalent to 359.997 meters. So that is the radius. Okay? Next would be compute the stationing of the PRC, point of reverse curve. Okay? So dito yon. So PRC. So station of the PRC. So ang stationing ng A natin, letter C. Station of PRC is equivalent to station PC plus L1 plus L1. Okay? So, compute muna natin si L1. L1 is equivalent to 2 pi R1 over 360 times I1. And that is equivalent to 2 pi times 59.997 divided by 360 times the I. 9 degrees, 33 minutes, 37.38 seconds. Therefore, L1 is equivalent to 2 times pi times 359.997 divided by 360 times 9 degrees, 33 minutes, 37.38 seconds. And that is equivalent to 60.069 meters. Therefore, station of the PRC is equivalent to 3 plus 420 plus 60.069. So, station of PRC is equivalent to 420 plus 60.069. That is equivalent to 3 plus 480.069. Okay? Okay, so number 10, two parallel tangents have directions of due east and are having 220 meter apart. So, two tangents, parallel sila, due east, are connected by a reversed curve having an equal radius of 750 meters for the radius. The PC of the curve is on the upper tangent. Okay, so upper tangent, so this is PC, and for the lower tangent, this is the PT. Okay, If the horizontal distance parallel to the tangent from the PT to the PC to the PT of the reverse curve is 790 meters. So, palitan natin. 790 meters. Letter A, compute the distance of the intermediate tangent between the curves. Okay? So, ano ba yung intermediate tangent? So, this is what we call the intermediate tangent. Okay? So, the intermediate tangent of the first curve, the intermediate tangent of the second curve. Okay? So, paano natin isosolve yan? Isosolve natin yan by looking at triangles. Okay? So, from the PC to the center of the intermediate, it is half of the 790 meters. And that is 790 meters. And that is 395 meters. Okay? And we're also given the vertical distance from the center of the curve to the center of the intermediate distance, which is 710. Okay? So if we are going to look at that, yung vertical is this, tapos yung horizontal naman is this. So, this is the vertical component, this is the horizontal component, this is the hypotenuse. Okay? Next, another equation would be, take note that the point of intersection with between the radius and the point of tangency, that is a 90-degree angle. Okay? So this is radius, and the radius is 850 meters. Okay? And since that is a right triangle, this is a right triangle, this is the uh, this is, let's say, this is the x component, this is the y component, this is the x component, this would be the hypotenuse. Okay? So if we are to do that, the equation of this line that is connecting the center of the curve to the origin of, from the origin of the curve to the intermediate, that would be 850 squared plus x squared, and get the square root. Okay? So, mangyayari niyan, we have here 850 squared plus x squared, square root, quantity squared is equivalent to the vertical 710 squared plus the horizontal of 395 squared. So squared will cancel here, likewise with the square root. Then we are left with 850 squared plus, wait. Okay, so palitan natin. Iba yung lalabas na value. Magne-negative, so that would be imaginary. Palitan natin, gawin natin 900 meters. Okay, 900 meters. So this would be 450. 450 meters. Okay, palitan natin to. So this is 900 meters. Okay, so that is equivalent to the vertical of 710. No. Kulang ng x. So, mali. So, 850 squared plus x squared is equivalent to the vertical of 710 squared plus 450 squared. Okay? So, combine similar terms. So, transpose this to the other side of the equation. We have x squared is equivalent to 710 squared plus 450 squared minus 850 squared. Okay? So, x squared is equivalent to 710 squared plus 450 squared minus 850 squared. Negative. Wait lang. We need to adjust. So, palitan ulit natin. This is 825. Please bear with me. Pinalitan ko kasi yung mga values, no? Para magkaroon tayo ng challenge. Okay? So, this is no longer 850, but 825. Okay? Okay. Okay. So that would be 25,975. Therefore, x is equivalent to, get the square root of 25975. That is equivalent to 161.168 meters. Okay? So the intermediate distance here, the first intermediate distance is 161.168. Likewise with the other intermediate here. Okay? Next, the distance o between the centers of the reversed curve or the point of origin to the point of origin. So again, ang equation natin dito is the square root of 825. So 825 squared. Okay? So this is letter A. This is letter B. So the distance is equivalent to the square root of 825 squared plus the value of x, which is 161.168 squared. Divide times 2 because there are two of them. So from this point to this point is D. From this point to this point is another distance. So D therefore is equivalent to 2 times the square root of 825 squared plus 161.168 squared. And that is equivalent to 1,681.19 meters. Okay? And letter C, determine or compute the stationing of the PT. If the station of the PC is 9 plus 138.35. Okay? So, kukunin natin yung PT. So, kunin muna natin yung L1. L1 is the same as L2 because they have the same radius. Okay? So, L1, wait. Kunin natin yung angle including the this one. Itong angle from here to here. Dito sa may intermediate. Then, kukunin natin yung angle ng intermediate alone. Let's say this is beta and this would be theta. Okay, so beta is equivalent to opposite over hypotenuse. Kaya sinama natin si theta dito kasi yung distance natin hanggang sa gitna or hanggang sa intermediate. Okay, so tangent beta is equivalent to 450 divided by 710. Okay, so beta therefore is equivalent to arc tangent of 450 divided by 710. Okay, beta now is equivalent to shift tangent 450 over 710. And that is equivalent to 32 degrees, 21 minutes, and 59.9 seconds. So that is beta. Okay? Now, alamin naman natin yung tangent theta. Okay? Take note, maliit na triangle yan. So, this is also a right triangle. This is the x, this is the y. And ito yung hypotenuse niya. Okay? So, tangent theta is equivalent to the value of x, and x is equivalent to 161.168 divided by 800. Pinalitan na natin yung radius natin. Our radius is now 825 meters divided by 825. Theta therefore is equivalent to arc tangent of 161.168 divided by 825. Theta therefore is equivalent to 161.168 over 825. And that is equivalent to 11 degrees, 3 minutes, 13.72 seconds. Okay? Therefore, the angle I is equivalent to 32 degrees, 21 minutes, 59.9 seconds minus 11 degrees, 3 minutes, 13.72 seconds. And that is equivalent to 59.9 seconds. And that is equivalent to 21 degrees, 18 minutes, 46.18 seconds. That is our interior angle. So we can now solve for our L. L is equivalent to 2 pi r divided by 360 degrees times I. And that is equivalent to 2 pi times the radius of, what is our radius? 825 divided by 360 times 21 degrees, 18 minutes, 46.18 seconds. Therefore, L is equivalent to 46.18 seconds. That is equivalent to 306.884 meters. Okay? So, solving for L, or station rather, station PT is equivalent to station PC plus 2 of X plus L, and that is also 2. So the station of PC is 9 plus 138.35 plus 161.168 times 2 plus the 306.884 times 2 din. Kasi dalawa yung dalawa din yung X. 2L, 2X. Okay? So, station of PC is equivalent to we have 138.35 plus 161.168 times 2 plus 306.884 times 2. Okay? Plus 9,000. Therefore, station PT is 10 plus 074.454. That is the station of PT. Two tangents converge at an angle of 30 degrees. So this is the first tangent, this is the second tangent. Direction of the second tangent is due east. The distance of the PC from the second tangent is 116.5 meter vertical distance. So from the PC to the horizontal tangent is 116.5 meter. The bearing of the common tangent is south 40 degrees going east. So this is the common tangent, south 40 degrees going east. Okay? So the angle of convergence here is 30 degrees. So by similar triangle, the angle of convergence here would also be 30 degrees. Okay? Now, we are given that the angle here is 50 degrees because from the south, where is that? The bearing, the bearing of the common tangent is south 40 degrees east. So from south, kung ito yung south natin, going 40 degrees. So with respect to the horizontal, we will be left with 50 degrees for the 50 degrees for the deflection. Okay? So the deflection here is 50 degrees. Therefore, the deflection also here would be 50 degrees. 50 degrees din dito. Then, 50 degrees din yung deflection natin dito. Okay? And if you're going to observe, the angle with respect to the the vertical here is 50 degrees. Therefore, with respect to the vertical also here, it would be 50 degrees since we have since the common radius here is the same, no? Parehas sila kasi common nga. Okay? So 50 degrees. So the with respect to the vertical, it is also 50 degrees. Okay? But this angle here by similar triangle would be equivalent to the angle here, the angle of convergence, which is 30 degrees. So that would be 30 degrees. So I2 is equivalent to 50 degrees minus 30 degrees, and that is equivalent to 50 minus 30, and that is 20 degrees. Okay, letter B. So compute if a reversed curve is to connect these two tangents, determine the common radius of the curve. Okay, so determine the common radius down. Now what value or what property can we use to start an equation? Okay, so hanap muna tayo ng magbibigay sa atin at least an equation. If you're going to check it here, from PC to PRC, the vertical distance is A. From PRC to B, the vertical distance is B. But from PC to the horizontal, the vertical distance is 116.5. Therefore, if we are to make an equation there, A plus B is equivalent to 116.5 meters. So, ang una na lang natin gagawin ngayon, what is the value of A and B? Okay, so ang gagawin natin, gagawa tayo ng triangle. Okay, so let us consider this as a triangle. So we will have here r cosine, r kasi nandito yung a natin, so it would be cosine 30 is equivalent to a over r. So we have here a is equivalent to cosine 30, cosine 30, cosine 30 is equivalent to a over the radius. So, ipunta na natin dun yung radius. Pero, take note, yung a dito natin, ito lang. Okay? So, ang gagawin natin, take note, from this point up to this point is, the angle naman, the angle involved is the 50 degrees. So, mangyayari, itong rectangle na to, isusubtract natin itong rectangle na to. So that, makakakuha tayo ng value for A. Okay? So that would be minus cosine 30, cosine 50 is equivalent to, we have here, r over A. Okay? Yan. So that would be our first equation. But we need to simplify it further. So that would be r, factor out r, we will be left with cosine 30 minus cosine 50. Simplifying that, cosine 30 minus cosine 50. That is equivalent to 0.223 r. Okay? We're not yet done because we do not have the value for B pa. Okay? So, B naman is equivalent to, we have here, ito. We have R minus yung triangle na mabubuo using naman this. Okay? So, ito. Ito yung B kasi. So, R minus itong angle natin. Itong angle na to. That would be cosine 50 times R. Okay? So, cosine 50 because it is adjacent. Itong side na to. Cosine 50 is equivalent to B over R. Okay? So, that would be R. So, factor out natin si R. We will be left with 1 minus cosine 50. So, we have 1 minus cosine 50. That is equivalent to 0.357 R. Okay? Using equation 1, using equation 1, A is equivalent to 0.223 R. So, from equation 1, 2 to 3 R plus 0.357 R is equivalent to 116.5. Okay, so 0.223 alpha x plus 0.357 alpha x is equivalent to 11.6.5. Shift solve. Therefore, the radius is equivalent to 200.862 meters. Okay? Lastly, we need to determine the stationing of PT. So stationing of the PT is equivalent to stationing of PC plus L1 plus L2. L1 is equivalent to 2 pi r over 360 times I. Substituting the value, we have 2 pi times the radius of 200.862 divided by 360, and our I1 is equivalent to 50 degrees. Therefore, L1 is equivalent to 2 pi times 200.862 times 360 times 50. That is equivalent to 175.285 meters. Okay. Next would be the L2. So L2 is equivalent to 2 pi r over 360 times I2. This is I1. So substituting, we have 2 pi times the radius of 200.862 divided by 360 times I2. What is our I2? That is 20 degrees. So, palitan lang natin dito si 20. And that is equivalent to 70.114 meters. Now, for station PT it is equivalent to 10 plus 620 plus 175.285. Take note, it will always be PC then the length of the curve. Okay, 175.285 plus 70.114 meters. Therefore, station PT is equivalent to 620 plus 175.285 plus 70.114. That is equivalent to 10 plus 865.399. Okay?